Long before the age of satellites and GPS, ancient sailors ventured across endless oceans, guided only by the shimmering patterns of stars above. These celestial maps, etched into the night sky, were more than just navigational tools. They were a testament to humanity's unyielding desire to understand the cosmos. This is the world of celestial cartography, the ancient art of mapping the heavens. For thousands of years, civilizations from the Babylonians to the Polynesians looked to the stars to chart their courses, tell their stories, and unlock the secrets of the universe. But how did they create these intricate star maps without the technology we rely on today? What deeper truths about our ancestors lie hidden in these celestial charts, and why, even in our modern world, do these ancient maps still hold such power to inspire and intrigue? In this video, we'll journey through the origins of celestial cartography, explore the ingenious techniques used by ancient stargazers, and uncover the cultural and historical significance of this timeless art. Together, we'll discover how the stars not only guided explorers across the seas, but also shaped the very fabric of human history and imagination. Let's dive into the mysteries of the cosmos and see how the art of mapping the stars continues to illuminate our world both then and now. The story of celestial cartography begins thousands of years ago in the fertile lands of Mesopotamia and along the banks of the Nile. Here, among the world's earliest civilizations, humans first turned their gaze upward, seeking meaning and order in the stars. For the ancient Mesopotamians, the night sky was more than a canvas of light. It was a divine script, a way to communicate with the gods. They meticulously recorded the movements of celestial bodies, creating some of the first known star catalogues. These early astronomers noticed patterns, cycles, and rhythms in the heavens, which they used to predict seasonal changes crucial for agriculture. The stars told them when to plant and when to harvest, linking the cosmos directly to survival. In Egypt, the night sky held a different kind of magic. The Egyptians associated the stars with their gods and the afterlife, believing that the heavens were a mirror of the divine order on earth. One of the most remarkable artifacts from this era is the Dendera zodiac, a stunning bas-relief found in a temple ceiling. This intricate map of the stars not only served as a guide to the heavens, but also reflected the spiritual beliefs of the time. The constellations depicted in the Dendera zodiac were tied to myths and rituals, showing how deeply astronomy was woven into the fabric of daily life. But these early star maps were more than just tools for farming or religious ceremonies. They were the first steps toward understanding the universe. The Babylonians, for instance, developed sophisticated mathematical techniques to track planetary movements, laying the groundwork for later astronomical discoveries. Their observations were so precise that they could predict eclipses and other celestial events with remarkable accuracy. These ancient stargazers didn't have telescopes or computers, yet their work was so advanced that it influenced astronomers for centuries to come. As these early systems of celestial mapping spread, they began to evolve. The knowledge of Mesopotamia and Egypt traveled across borders, blending with the traditions of other cultures. The Greeks, for example, would later build on these foundations, creating more detailed star charts and introducing new concepts about the structure of the cosmos. But even as the tools and techniques improved, the core idea remained the same. The stars were a guide, a source of wonder, and a way to make sense of the world. What's fascinating is how these ancient practices were not just about observation, but also about storytelling. The constellations we recognize today, like Orion, Taurus, and the Big Dipper, were first named and mapped by these early civilizations. Each star pattern carried a myth, a legend, or a lesson, turning the night sky into a vast tapestry of human imagination. These stories were passed down through generations, connecting people to the stars in ways that went far beyond science. So, while the tools of celestial cartography have changed dramatically over the millennia, the desire to map the heavens has remained a constant thread in human history. From the clay tablets of Babylon to the temple ceilings of Egypt, these ancient star maps remind us of our enduring fascination with the cosmos. And as we'll see next, this fascination only grew stronger, leading to even more sophisticated ways of understanding the stars. The stars above were never just points of light to ancient civilizations. They were characters in grand cosmic tales immortalized in the night sky. Mythology and star mapping were inseparable, with every constellation carrying a story that brought the heavens to life. For the Greeks, the constellation Orion wasn't merely a pattern of stars. It was the legendary hunter forever pursuing the Pleiades across the sky, his story etched into the stars for all to see. Similarly, Ursa Major, the Great Bear, was said to represent Callisto, a nymph transformed into a bear by the jealous goddess Hera. These myths weren't just imaginative tales, they were tools for remembering the stars. By attaching vivid stories to celestial patterns, ancient cultures turned the night sky into a living map, one that was both easy to navigate and deeply meaningful. This blending of mythology and astronomy wasn't unique to the Greeks. Across the world, cultures used stories to make sense of the stars. In Mesopotamia, the constellation we know as Taurus was linked to the Epic of Gilgamesh, symbolizing the bull of heaven sent to punish the hero. In Polynesia, navigators relied on star lore passed down through generations, with constellations like the Southern Cross guiding them across vast oceans. Each culture saw its own heroes, gods, and legends reflected in the stars, creating a celestial tapestry that connected the heavens to human experience. But why did these stories matter so much? Beyond their beauty, myths served as practical memory aids. In a world without written star charts, storytelling was a way to preserve knowledge. A sailor could remember the position of Orion's belt or the curve of Ursa Major's tail because they were tied to unforgettable tales. These stories also helped people feel connected to the cosmos, weaving the stars into their daily lives and spiritual beliefs. The heavens weren't distant or impersonal. They were a stage where divine dramas unfolded, a mirror of the world below. This deep connection between mythology and star mapping reveals something profound about ancient worldviews. The stars weren't just objects to study, they were part of a larger narrative about humanity's place in the universe. By mapping the heavens with stories, ancient cultures transformed the sky into a shared cultural heritage, one that continues to inspire us today. As we move forward, we'll see how these mythological foundations laid the groundwork for even more sophisticated understandings of the cosmos, blending art, science, and spirituality in ways that still resonate with us. The ingenuity of ancient astronomers is perhaps most vividly seen in the tools they created to map the stars. Without the advanced technology we have today, these early stargazers relied on simple yet remarkably effective instruments to measure the heavens. Take the astrolabe, for example, a handheld device that looked like an intricate metal disc covered in finely etched markings. Used widely in the Islamic world and later in medieval Europe, the astrolabe allowed astronomers to determine the positions of stars and planets, calculate time, and even predict the rising and setting of celestial bodies. Crafted with painstaking precision, these devices were marvels of engineering, blending artistry with functionality. Each astrolabe was a testament to the skill of its maker, often customized for specific latitudes to ensure accuracy. Another key instrument was the armillary sphere, a complex model of the celestial sphere made up of interlocking rings. These rings represented key circles of the sky, such as the equator, the ecliptic, and the horizon. By rotating the rings, astronomers could simulate the movement of celestial bodies and track their paths across the sky. Armillary spheres weren't just tools for observation. they were also teaching aids, helping students visualize the cosmos in 3 dimensions. The Greeks and Chinese were among the first to develop these devices, and their designs influenced astronomers for centuries, but not all tools were so elaborate. Some of the most effective instruments were deceptively simple. Ancient Polynesian navigators, for instance, used nothing more than their hands and a keen understanding of the stars to guide their canoes across vast stretches of open ocean. By holding their fingers at specific angles, they could measure the altitude of stars and determine their position relative to the horizon. These techniques, passed down through generations, allowed them to traverse thousands of miles with astounding accuracy, proving that sometimes the most powerful tools are the ones we carry within us. Of course, these ancient astronomers faced significant challenges. Without the precision instruments we have today, they had to rely on careful observation and meticulous record-keeping. Errors in measurement could lead to flawed star maps, so accuracy was paramount. The lack of artificial light also meant that observations were often made under ideal conditions: clear, dark skies far from the distractions of cities. Yet, despite these limitations, they managed to create remarkably detailed and accurate charts of the heavens. What's truly remarkable is how these tools reflect a universal human trait: curiosity. The astrolabe, the armillary sphere, and even the simple sighting techniques of Polynesian navigators were all born from a desire to understand the cosmos. Each tool was a step forward, a way to bridge the gap between Earth and sky. And while these instruments may seem primitive by today's standards, they laid the foundation for the astronomical advancements that would follow. As we'll see next, this quest to map the stars didn't end with these early tools. It was just the beginning of a journey that continues to this day. The Greeks took the art of celestial mapping to new heights, transforming it from a collection of observations into a sophisticated science. Among the most influential figures was Hipparchus, often called the father of trigonometry. Working in the 2nd century BCE, he compiled one of the earliest known star catalogues, meticulously recording the positions and brightness of over 1,000 stars. His work wasn't just about cataloging, it was about precision. Hipparchus developed methods to measure the distances between stars and introduced the concept of stellar magnitudes, or the brightness of stars as seen from Earth. This groundbreaking system, still in use today, allowed astronomers to compare stars in a way that was both systematic and scientific. But Hipparchus didn't stop there. He also discovered the precession of the equinoxes, a slow wobble in Earth's axis that gradually shifts the position of the stars over time. This discovery was a monumental leap in understanding the dynamic nature of the cosmos. Building on Hipparchus's foundation, Claudius Ptolemy took Greek astronomy even further. In the 2nd century CE, Ptolemy wrote the Almagest, a 13-volume masterpiece that became the definitive guide to the stars for over 1,000 years. The Almagest wasn't just a star catalogue, it was a comprehensive system that explained the motions of the planets and stars using a geocentric model, with Earth at the center of the universe. While this model was later proven incorrect, it was remarkably accurate for its time, capable of predicting planetary positions with impressive precision. Ptolemy's work also included detailed star maps and mathematical tools for calculating celestial movements, making it an indispensable resource for astronomers across the ancient world. The influence of Ptolemy's Almagest cannot be overstated. When the Islamic Golden Age dawned in the 8th century, scholars eagerly translated the text into Arabic, preserving and expanding upon its knowledge. Islamic astronomers like al-Battani and al-Sufi refined Ptolemy's calculations, correcting errors and adding new observations. These advancements eventually made their way to medieval Europe, where the Almagest became a cornerstone of Renaissance astronomy. Figures like Copernicus and Kepler studied Ptolemy's work, using it as a springboard for their own revolutionary ideas. In many ways, the Almagest served as a bridge between ancient and modern astronomy, connecting the knowledge of the Greeks to the scientific revolutions that followed. What's truly remarkable about Greek astronomy is how it transcended its time and place. The ideas of Hipparchus and Ptolemy didn't just stay within the borders of Greece. They traveled across continents and centuries, shaping the way countless cultures understood the stars. This cultural exchange highlights the universality of astronomy as a pursuit, one that transcends language, geography, and time. The Greeks didn't just map the stars, they created a framework for understanding the cosmos that would inspire generations to come. As we move forward, we'll see how these ancient ideas continue to evolve, blending with the traditions of other cultures and paving the way for the astronomical breakthroughs of the modern era. The story of celestial cartography is far from over. It's a journey that has been thousands of years in the making and one that continues to unfold even today. During the Islamic Golden Age, a period spanning from the 8th to the 14th century, the art of celestial cartography experienced a remarkable revival. As Europe grappled with the so-called Dark Ages, Islamic scholars became the torchbearers of astronomical knowledge, preserving and expanding upon the works of the Greeks. This era wasn't just about safeguarding ancient texts, it was a time of innovation where new ideas flourished and old ones were refined to unprecedented levels of precision. One of the most influential figures of this period was Abd al-Rahman al-Sufi, a Persian astronomer whose work bridged the gap between observation and artistry. In the 10th century, al-Sufi published his Book of Fixed Stars, a masterpiece that updated and expanded Ptolemy's star catalogue. What set al-Sufi apart was his meticulous attention to detail. He didn't just list the stars, he mapped them with remarkable accuracy, incorporating both Greek and Arabic names for constellations. His work also included beautiful illustrations, transforming the night sky into a visual feast that blended science and art. Al-Sufi's catalogue became a cornerstone of Islamic astronomy, influencing scholars for centuries and even reaching as far as China. But the Islamic Golden Age wasn't just about cataloguing stars, it was also a time of technological advancement. Instruments like the astrolabe reached new levels of sophistication under Islamic craftsmanship. These devices, which had been introduced by the Greeks, were refined and adapted to suit the needs of Islamic astronomers. The astrolabe became more than just a tool for navigation. It was a portable computer of sorts, capable of solving complex astronomical problems with ease. Islamic scholars also developed other instruments such as the quadrant and the celestial globe, which allowed for even more precise measurements of the heavens. Perhaps one of the most significant contributions of this era was the translation movement. Islamic scholars, recognizing the value of Greek knowledge, embarked on an ambitious project to translate works like Ptolemy's Almagest into Arabic. This wasn't a simple act of preservation, it was a transformative process. As these texts were translated, they were also scrutinized, corrected, and expanded. Errors in Ptolemy's calculations were identified and rectified, and new observations were added to reflect the latest discoveries. This effort didn't just keep ancient knowledge alive, it breathed new life into it, creating a richer, more accurate understanding of the cosmos. The impact of these translations extended far beyond the Islamic world. As Europe began to emerge from the Middle Ages, these Arabic texts found their way into the hands of Renaissance scholars. Figures like Gerard of Cremona, who translated Arabic works into Latin, played a crucial role in reintroducing Greek astronomy to the West. This exchange of knowledge marked a turning point in the history of science, as the works of Islamic astronomers became the foundation for the astronomical breakthroughs of the Renaissance. What's striking about this period is how it exemplifies the universality of human curiosity. Islamic scholars didn't see themselves as separate from the Greeks or the Europeans. They saw themselves as part of a continuous tradition of learning. Their work wasn't just about preserving the past, it was about building a bridge to the future. And as we'll see next, this bridge would lead to some of the most revolutionary discoveries in the history of astronomy, forever changing the way we understand the cosmos. While the Greeks and Islamic scholars were making strides in mapping the heavens, Chinese astronomers were crafting their own celestial traditions, blending practicality with profound symbolism. In China, the stars weren't just navigational aids or scientific curiosities, they were deeply tied to the empire's governance and spiritual beliefs. The Chinese saw the sky as a reflection of Earth, with celestial events serving as omens that could influence the fate of the nation. This belief made astronomy a matter of state importance, and astronomers held positions of great prestige, tasked with interpreting the heavens for the emperor. One of the most remarkable artifacts from this tradition is the Dunhuang Star Atlas, a stunning hand-drawn map dating back to the Tang dynasty around the 7th century. This ancient document is one of the oldest surviving star charts in the world, and its precision is nothing short of astonishing. The atlas depicts over 1,300 stars, grouped into constellations that reflect both Chinese mythology and practical observation. Unlike Western star maps, which often focus on individual constellations, the Dunhuang Atlas presents the entire night sky as a unified whole, divided into sections that correspond to the 28 lunar mansions, a system unique to Chinese astronomy. These mansions served as a celestial calendar, guiding agricultural activities and ceremonial events throughout the year. What makes the Dunhuang Star Atlas particularly fascinating is its dual purpose. On one hand, it was a scientific tool, providing detailed information about the positions and movements of stars. On the other, it was a symbolic map reflecting the Chinese worldview. The stars were believed to mirror the hierarchy of the imperial court, with the North Star representing the emperor and surrounding constellations symbolizing his ministers and subjects. This fusion of science and symbolism highlights how deeply astronomy was woven into the cultural and political fabric of ancient China. Chinese astronomers also made significant contributions to the development of celestial cartography. They were among the first to record supernova, comets, and other astronomical phenomena, often interpreting these events as divine messages. The meticulous records they kept, known as star logs, were invaluable resources for later generations, offering insights into the behavior of the cosmos over centuries. These records weren't just scientific, they were also practical, helping to predict seasonal changes, guide agricultural cycles, and ensure the stability of the empire. Yet, Chinese astronomy wasn't isolated from the rest of the world. While it developed its own unique systems, it also absorbed and exchanged knowledge with neighboring cultures. The Silk Road, for example, facilitated the flow of ideas between China and the Islamic world, leading to a rich cross-pollination of astronomical traditions. This exchange underscores a broader truth. The quest to understand the stars was a shared human endeavor, transcending borders and civilizations. As we look at the Dunhuang Star Atlas and the broader traditions of Chinese astronomy, we see a culture that viewed the heavens not just as a scientific challenge, but as a source of meaning and order. Their approach to celestial mapping was both practical and poetic, a testament to the enduring human desire to connect with the cosmos. And as we'll explore next, this desire would continue to evolve, shaping the way we understand the stars in ways that are still relevant today. As empires rose and trade routes expanded, the stars became more than just symbols in the sky. They became lifelines for explorers venturing into the unknown. Celestial cartography played a pivotal role in navigation, offering sailors a way to traverse vast oceans and discover new lands long before the invention of modern instruments. The North Star, or Polaris, was perhaps the most crucial of these celestial markers. Positioned almost directly above the Earth's North Pole, it provided a fixed point of reference, allowing navigators to determine their latitude with remarkable accuracy. By measuring the angle between the horizon and Polaris, sailors could estimate how far north or south they were, a technique that became indispensable for long voyages. But Polaris wasn't the only star that guided them. Constellations like Orion, the Southern Cross, and the Big Dipper also served as celestial signposts, their predictable movements helping sailors chart their course across the seas. Navigating by the stars, however, was no simple feat. Unlike today's GPS systems, which offer real-time updates and pinpoint accuracy, celestial navigation required a deep understanding of the night sky. Sailors had to account for the Earth's rotation, which caused the stars to shift position throughout the night, as well as seasonal changes that altered the visibility of certain constellations. Weather posed another challenge. Cloudy skies could obscure the stars for days, leaving ships adrift without a reliable way to determine their location. Despite these difficulties, ancient and medieval mariners developed ingenious methods to overcome these obstacles. The astrolabe, for instance, allowed them to measure the altitude of stars even on rocky seas, while the cross staff provided a simpler way to gauge angles between celestial bodies and the horizon. Over time, celestial cartography evolved to meet the growing demands of exploration. Star charts became more detailed, incorporating new discoveries and refining existing constellations. The invention of the sextant in the 18th century marked a significant leap forward, enabling sailors to measure angles with greater precision and accuracy. These advancements didn't just make navigation easier, they made it possible to explore regions of the world that had once been considered unreachable. The voyages of explorers like Christopher Columbus, Ferdinand Magellan, and Zheng He were made possible by the knowledge of the stars, as their ships followed celestial maps across uncharted waters. But celestial navigation wasn't just about practicality, it was also about possibility. Star maps didn't just tell sailors where they were, they hinted at where they could go. They transformed the vast, intimidating expanse of the ocean into a navigable network of routes, each marked by the light of distant stars. In this way, celestial cartography became more than a scientific tool. It became a key to exploration, unlocking new worlds and reshaping humanity's understanding of the Earth. The stars, once seen as distant and untouchable, became guides, companions, and even co-conspirators in the great age of discovery. As we journey further into the story of celestial cartography, we'll see how this art continued to evolve, not just as a tool for navigation, but as a way to explore the very limits of human knowledge and ambition. The stars, it turns out, were not just a map, they were a mirror, reflecting our endless curiosity and our desire to reach beyond the horizon. The Renaissance marked a turning point in the story of celestial cartography, a time when the heavens were rediscovered with fresh eyes and boundless curiosity. As Europe emerged from the Middle Ages, a wave of intellectual revival swept across the continent, fueled by the rediscovery of ancient Greek and Roman texts. Works like Ptolemy's Almagest, preserved and expanded by Islamic scholars, found their way back into European hands, sparking a renewed fascination with the stars. But this wasn't just about revisiting old knowledge, it was about building on it, pushing the boundaries of what humanity could understand about the cosmos. The invention of the telescope in the early 17th century added a thrilling new dimension to this quest, allowing astronomers to peer deeper into the night sky than ever before. One of the most influential figures of this era was Tycho Brahe, a Danish astronomer whose meticulous observations revolutionized celestial mapping. Unlike his predecessors, Brahe didn't rely solely on ancient texts or naked eye observations. Instead, he built some of the most precise instruments of his time, including massive quadrants and sextants, to measure the positions of stars and planets with unprecedented accuracy. His observatory, Uraniborg, became a hub of scientific activity, where he compiled detailed records of celestial movements that would later prove invaluable. Brahe's work laid the groundwork for a new understanding of the cosmos, one that moved beyond the geocentric model of Ptolemy and toward a more dynamic, sun-centered view of the universe. Building on Brahe's foundation, Johannes Kepler took celestial cartography to even greater heights. Kepler, a mathematician and astronomer, used Brahe's data to formulate his laws of planetary motion, which described how planets orbit the Sun in elliptical paths rather than perfect circles. This discovery was a seismic shift in astronomy, challenging centuries of established thought and paving the way for Isaac Newton's later work on gravity. Kepler's Rudolphine tables, a star catalogue and set of planetary tables, became an essential tool for astronomers, offering precise predictions of celestial events that were unmatched in their accuracy. His work didn't just refine star maps, it redefined how we understand the mechanics of the universe. But the Renaissance wasn't just about science, it was also about art. Celestial atlases from this period were masterpieces of both precision and beauty, blending meticulous observation with stunning visual design. Take, for example, the work of Andreas Cellarius, whose Harmonia Macrocosmica remains one of the most breathtaking celestial atlases ever created. Filled with intricate illustrations and elaborate diagrams, the Harmonia Macrocosmica wasn't just a scientific tool. It was a work of art, capturing the wonder and complexity of the cosmos in vivid detail. These atlases reflected the Renaissance ideal of harmonizing art and science, showing that the pursuit of knowledge could also be a celebration of creativity. What makes this period so extraordinary is how it set the stage for the modern era of astronomy. The Renaissance wasn't just a revival of ancient knowledge, it was a leap forward, a time when humanity began to see the universe in a new light. The work of Brahe, Kepler, and others didn't just refine star maps, it reshaped our understanding of the cosmos, laying the foundation for the scientific revolutions that would follow. And as we'll see next, this era of discovery was just the beginning of a journey that would take us even further into the mysteries of the stars. The beauty of celestial maps lies not only in their scientific precision, but also in their breathtaking artistry. For centuries, the night sky has inspired artists and astronomers alike, who collaborated to create maps that were as much about wonder as they were about navigation. These maps weren't just tools for understanding the cosmos, they were masterpieces blending meticulous observation with imaginative design. Imagine unrolling a medieval manuscript, its pages adorned with hand-painted constellations, their golden stars shimmering against deep blue parchment. Every line, every detail was a labor of love crafted to capture the majesty of the heavens. One of the most striking examples of this marriage of art and science is Andreas Cellarius's Harmonia Macrocosmica, published in the mid-17th century. This celestial atlas is a visual feast, filled with elaborate engravings that depict the cosmos in vivid detail. From swirling depictions of planetary orbits to intricate diagrams of celestial spheres, each page is a testament to the creativity and skill of its creators. Cellarius didn't just map the stars, he transformed them into a symphony of shapes and colors, inviting viewers to see the universe not just as a collection of points of light, but as a living, dynamic work of art. The Harmonia Macrocosmica wasn't just a scientific document, it was a celebration of the beauty and mystery of the cosmos. But this artistic tradition didn't begin with Cellarius. Medieval manuscripts often featured stunning celestial illustrations, where constellations were brought to life as mythical figures and celestial creatures. These images were more than just decorative, They were a way to make the stars memorable, turning abstract patterns into vivid stories. In some cases, these illustrations were so detailed that they included zodiac signs, planetary movements, and even the phases of the moon, all rendered with a painter's touch. These maps were often commissioned by wealthy patrons or religious institutions who saw them as symbols of both knowledge and divine inspiration. The collaboration between artists and astronomers was crucial to this process. Astronomers provided the data, ensuring that the positions of stars and planets were accurate, while artists brought that data to life, infusing it with color, texture, and imagination. This partnership wasn't just practical, it was transformative. By combining the rigor of science with the creativity of art, they created maps that were both functional and deeply moving. These celestial atlases weren't just meant to be studied, they were meant to be experienced, to inspire awe and curiosity in anyone who gazed upon them. What's remarkable is how these maps continue to captivate us today. Even in an age of digital star charts and high-resolution telescopes, the hand-drawn beauty of these ancient and Renaissance maps holds a unique charm. They remind us that the stars are more than just objects to study. They are a source of wonder, a canvas for human imagination, and a bridge between science and art. As we move forward, we'll see how this artistic legacy influenced not only the way we map the stars, but also how we see ourselves in the vast expanse of the universe. Celestial maps are more than just scientific tools, they are windows into the hearts and minds of the societies that created them. Each star chart, constellation, and celestial diagram carries the imprint of the culture that produced it, reflecting its values, beliefs, and priorities. The way a society mapped the stars tells us not only about its understanding of the cosmos, but also about its place within it. From the grand imperial symbolism of China to the adventurous spirit of European explorers, star maps reveal the rich diversity of human thought and imagination. In China, the night sky was deeply entwined with the concept of cosmic order and imperial authority. The emperor was seen as the son of heaven, a ruler whose mandate was divinely ordained. The stars, therefore, weren't just points of light, they were symbols of power and hierarchy. The North Star, known as the Purple Forbidden Enclosure, represented the emperor himself, while surrounding constellations were likened to his courtiers and subjects. This celestial mirror of the earthly realm wasn't just poetic, it was practical. Chinese astronomers used the stars to predict events that could impact the empire, from natural disasters to political upheavals. The meticulous star logs they kept were more than scientific records. They were tools of governance, ensuring the stability and prosperity of the state. Meanwhile, in Europe, the stars took on a different role. During the Age of Exploration, celestial maps became essential tools for navigation, enabling sailors to venture into uncharted waters and expand the known world. The constellations weren't just mythic figures or divine symbols, they were guides, marking the way to new lands and opportunities. This practical focus on exploration reflected the broader cultural shift of the Renaissance, a time when curiosity and ambition drove humanity to push the boundaries of knowledge. European star maps from this period often featured detailed illustrations of ships, compasses, and navigational tools, emphasizing the connection between the heavens and the quest for discovery. But cultural interpretations of the stars weren't limited to governance or exploration. In many societies, star maps played a central role in rituals and calendars. For the Maya, for example, the night sky was a sacred text filled with omens and messages from the gods. Their intricate calendars, based on precise astronomical observations, guided everything from agricultural cycles to religious ceremonies. Similarly, in ancient Egypt, the annual rising of the star Sirius marked the beginning of the Nile flood, a vital event that ensured the fertility of the land. These celestial events weren't just observed, they were celebrated, woven into the fabric of daily life and spiritual practice. What's fascinating is how different cultures could look at the same stars and see entirely different stories. The constellation we know as Orion, for instance, was seen by the Greeks as a mighty hunter, while in Aboriginal Australian traditions, the same stars represented a group of brothers pursuing a kangaroo. These varied interpretations highlight the universal human impulse to find meaning in the stars, even as the meanings themselves reflect the unique perspectives of each culture. Star maps, in this sense, are not just scientific artifacts, they are cultural documents, capturing the ways in which humanity has sought to understand its place in the universe. As we explore these diverse interpretations, we're reminded of the richness of human imagination. The stars, in their unchanging brilliance, have been a canvas for countless stories, beliefs, and aspirations. Each culture has painted its own picture on this celestial canvas, creating a tapestry that is as varied as it is profound. And as we move forward, we'll see how these cultural legacies continue to shape our understanding of the stars, reminding us that the heavens are not just a place of science, they are a mirror of who we are. As we trace the history of celestial cartography, we encounter tantalizing gaps in the story, star maps that once existed but have since vanished, leaving behind only fragments and whispers of their existence. Among the most intriguing are the lost star maps of the Maya, a civilization renowned for its advanced understanding of astronomy. The Maya meticulously tracked the movements of the sun, moon, and planets, using this knowledge to create calendars and predict celestial events. Yet, much of their astronomical knowledge, including detailed star charts, has been lost to time. The few surviving artifacts, like the Dresden Codex, offer glimpses into their sophisticated system, but much remains shrouded in mystery. What star maps did they create, and what secrets might they have held about their view of the cosmos? The challenge of reconstructing these lost maps is daunting. Unlike the well-preserved star catalogues of the Greeks or the detailed atlases of the Renaissance, many ancient star maps exist only as scattered references in texts or as faint traces in archaeological remains. Take, for instance, the case of the Polynesians, who relied on celestial navigation to traverse the vast Pacific Ocean. While their navigational techniques were legendary, their star maps were often passed down orally, leaving no physical records behind. Modern researchers must piece together these traditions from oral histories, surviving artifacts, and the stars themselves, which still shine as they did centuries ago. It's a bit like trying to solve a puzzle with half the pieces missing. Each clue is precious, but the full picture remains elusive. Yet, even in their fragmentary state, these lost maps offer tantalizing clues. For example, the Nazca lines of Peru, enormous geoglyphs etched into the desert, have been theorized to align with celestial patterns. Some researchers suggest they may have served as a kind of star map, guiding ancient peoples in their agricultural or ceremonial cycles. Similarly, the alignment of ancient monuments like Stonehenge or the Great Pyramid of Giza with celestial bodies hints at a deep connection between architecture and astronomy. These structures may not be star maps in the traditional sense, but they reflect a shared human impulse to map the heavens in whatever form was available. Modern technology is helping to bridge these gaps, offering new ways to rediscover and interpret these lost treasures. Advanced imaging techniques such as LiDAR allow researchers to uncover hidden structures and patterns that might hold astronomical significance. Meanwhile, computer algorithms can analyze ancient texts and artifacts to identify potential star maps or celestial references that might otherwise go unnoticed. Even the stars themselves are providing clues, as astronomers use modern telescopes to trace the positions of celestial bodies as they would have appeared thousands of years ago. These tools are opening up new possibilities for understanding how ancient cultures viewed the cosmos. What makes these lost star maps so captivating is not just the mystery of what they contained, but the way they remind us of the fragility of knowledge. Civilizations rise and fall, and with them, their understanding of the stars can vanish, only to be rediscovered centuries later. These maps are more than just historical artifacts. They are windows into the minds of the people who created them, offering insights into how they saw themselves in relation to the universe. And as historians and astronomers continue to piece together these fragments, they're not just uncovering the past, they're rekindling a connection to the stars that has inspired humanity for millennia. The allure of these lost star maps lies not only in what they might reveal, but in the questions they provoke. What other celestial knowledge has been lost to time, and what might we still discover about the ancient world's relationship with the stars? As we explore these mysteries, we're reminded that the heavens have always been a source of wonder, a canvas for human imagination, and a guide for our journey through time. And as we'll see next, this journey is far from over. It's one that continues to unfold even in the modern era. At the heart of celestial cartography lies a fascinating blend of science and ingenuity principles that allowed ancient astronomers to map the vast, three-dimensional expanse of the night sky onto flat surfaces with remarkable precision. One of the most fundamental tools in this process is the system of celestial coordinates, which works much like latitude and longitude on Earth. Imagine the sky as a giant sphere surrounding our planet, with the Earth's equator projected outward to create the celestial equator. From there, astronomers use declination, measured in degrees north or south of this equator, and right ascension, measured in hours eastward from a fixed point, to pinpoint the exact location of stars and planets. This system, refined over centuries, forms the backbone of star maps, transforming the chaotic tapestry of the night sky into an orderly grid that anyone can follow. Another critical concept in celestial mapping is star magnitude, a measure of a star's brightness as seen from Earth. The ancient Greek astronomer Hipparchus first introduced this idea, categorizing stars into 6 magnitudes, with the brightest being first magnitude and the faintest, barely visible to the naked eye, as 6th magnitude. This system was later expanded with the invention of telescopes, which revealed stars far too dim for the naked eye to see. Today, astronomers use a logarithmic scale to measure brightness, allowing for even greater precision. Understanding star magnitudes wasn't just about cataloging stars, it was about unraveling the secrets of the cosmos, from the life cycles of stars to the vast distances that separate them. But mapping the stars isn't as simple as plotting points on a flat grid. One of the greatest challenges astronomers faced was the precession of the equinoxes, a slow wobble in Earth's axis that causes the positions of the stars to shift over time. Discovered by Hipparchus in the 2nd century BC, this phenomenon means that the celestial poles, the points around which the stars appear to rotate, gradually move in a circular pattern over a cycle of about 26,000 years. This shift has profound implications for star maps, as constellations that were once prominent in the night sky slowly drift out of view while others take their place. Accounting for this movement required not only precise observations, but also a deep understanding of the Earth's place in the cosmos. Compounding the challenge was the task of translating a 3-dimensional sky onto a 2-dimensional surface. Unlike a globe, which can accurately represent the Earth's curvature, flat star maps inevitably distort the positions and shapes of constellations. To overcome this, astronomers developed various projection techniques, each with its own strengths and limitations. For example, the Mercator projection, commonly used for world maps, was adapted for celestial charts, preserving the angles between stars but distorting their distances. Other methods, like the stereographic projection, prioritized accuracy in specific regions of the sky. These innovations in mapping were as much about creativity as they were about science, requiring astronomers to think outside the bounds of traditional geometry. What makes these scientific principles so remarkable is how they reveal the interconnectedness of the universe. Celestial coordinates, star magnitudes, and the precession of the equinoxes aren't just abstract concepts, they're tools that help us navigate not only the night sky but also the broader mysteries of space and time. Each discovery built on the last, from Hipparchus's early observations to the sophisticated instruments of the Renaissance, creating a foundation for modern astronomy. These advancements didn't just refine our maps of the stars, they transformed our understanding of the cosmos, showing us that the heavens are not static but dynamic, ever-changing, and infinitely complex. As we continue to explore the science behind celestial mapping, we'll see how these principles laid the groundwork for even greater discoveries, from the laws of planetary motion to the exploration of distant galaxies. The stars, once seen as fixed and unchanging, became a gateway to understanding the universe in motion, a testament to humanity's relentless curiosity and ingenuity. And as our journey through the history of celestial cartography unfolds, we'll discover how these scientific breakthroughs continue to shape the way we see the world and our place within it. The names we give to stars and constellations are more than just labels, they are windows into the cultures that named them, reflecting their values, beliefs, and priorities. Take Sirius, for example, the brightest star in the night sky. To the ancient Egyptians, Sirius was known as Sopdet, a celestial herald whose appearance coincided with the annual flooding of the Nile, a life-giving event that sustained their agriculture. For the Greeks, Sirius was the scorcher, associated with the heat of summer and the myth of Orion's faithful hunting dog. These differing interpretations of the same star reveal how societies projected their own stories and concerns onto the heavens, turning the stars into a canvas for human imagination. Polaris, the North Star, offers another fascinating example. While modern navigators rely on Polaris for its fixed position above the Earth's North Pole, its significance has varied across cultures. To the ancient Greeks, it was part of the constellation Ursa Minor, the Little Bear. In Chinese astronomy, Polaris held a central role in the celestial bureaucracy, symbolizing the emperor's authority. Even the name Polaris itself, derived from the Latin word for pole, reflects its navigational importance in European exploration. Each name carries with it a piece of history, a glimpse into how different societies saw themselves in relation to the cosmos. Vega, one of the brightest stars in the summer sky, has its own rich tapestry of stories. In Arabic tradition, Vega was part of the constellation Al-Nasr al-Waqi, the swooping eagle, a name that later evolved into its modern form. For the ancient Chinese, Vega was part of the myth of the cowherd and the weaver girl, a tale of love and separation that played out in the stars. These stories weren't just poetic, they were practical, helping people remember and identify stars in a time before printed star charts. The names we use today are often relics of these ancient traditions, passed down through generations and across cultures. But as astronomy evolved from an art into a science, the need for standardization became clear. Enter the International Astronomical Union, or IAU, founded in 1919. One of its primary tasks was to bring order to the chaos of star names, many of which varied by culture and language. The IAU established a system for naming stars and constellations that prioritized clarity and consistency, ensuring that astronomers around the world could communicate effectively. Today, stars are officially designated by numbers and coordinates, but their traditional names like Sirius, Vega, and Polaris remain in use as a nod to their rich cultural histories. This evolution of star naming conventions tells a larger story about humanity's relationship with the stars. What began as a way to make sense of the night sky through myths, stories, and practical observations has become a global effort to understand the cosmos with precision and rigor. Yet, even as we've moved toward standardization, the old names endure, a reminder of the countless ways we've tried to connect with the heavens. These names are more than just markers in the sky. They are threads in the tapestry of human history, linking us to the countless generations who looked up and wondered just as we do. As we continue to explore the stars, we're not just mapping the cosmos, we're mapping our own journey, a story that stretches back to the dawn of humanity and forward into the unknown. And in that story, the names we give to the stars are more than just words. They are echoes of our shared past and our enduring curiosity about the universe. The stars have always been more than just points of light in the night sky. They've been seen as messengers, omens, and even guides to human destiny. This belief lies at the heart of astrology, a practice that has intertwined with celestial cartography for thousands of years. While modern science distinguishes astronomy from astrology, the two were once inseparable. Ancient astronomers didn't just map the stars to understand their movements. They also sought to decode their meaning, believing that the heavens held clues to the future and the fate of individuals and empires alike. This connection between the stars and human life gave rise to one of the most enduring uses of celestial maps, astrological star charts. In ancient Mesopotamia, the birthplace of astrology, celestial cartography was deeply tied to divination. Priests and scholars meticulously recorded the positions of planets and stars, believing that celestial events like eclipses or the appearance of comets were signs from the gods. These observations were compiled into detailed star charts, which astrologers used to predict everything from harvests to the outcomes of wars. The Enuma Anu Enlil, a series of cuneiform tablets dating back to the 7th century BCE, is one of the earliest known collections of astrological omens. It reveals how the Babylonians saw the stars not just as navigational tools but as a cosmic language, one that could be deciphered to reveal the will of the gods. The Greeks took this idea even further, blending Mesopotamian astrology with their own philosophical traditions. Figures like Claudius Ptolemy, whose work Tetrabiblos became a cornerstone of Western astrology, argued that the positions of the stars at the moment of a person's birth could influence their character and destiny. To create these personalized star charts or horoscopes, astrologers relied on the same celestial coordinates and star maps used by astronomers. The zodiac, a band of 12 constellations through which the sun appears to travel over the course of a year, became a central feature of these charts. Each constellation was associated with specific traits and influences, turning the night sky into a kind of cosmic clock that ticked with the rhythms of human life. Astrological star charts weren't just tools for individual divination, they also played a significant role in shaping the decisions of rulers and empires. In medieval Europe, kings and queens often consulted astrologers before making major political or military decisions. The belief that celestial events could foretell the rise and fall of leaders led to the creation of elaborate astrological almanacs filled with star maps and predictions. Even the timing of coronations and battles was sometimes determined by the stars, reflecting the deep cultural significance of astrology in shaping the course of history. What's fascinating is how astrology influenced the development of celestial cartography itself. The need for precise astrological predictions drove improvements in star mapping as astrologers demanded more accurate and detailed charts. This, in turn, spurred advancements in astronomical instruments and techniques, creating a feedback loop between the two fields. The astrolabe, for example, was as much a tool for casting horoscopes as it was for navigating the seas. This interplay between astrology and astronomy reveals how the desire to understand the stars has always been driven by both curiosity and the quest for meaning. While astrology and astronomy eventually diverged, the legacy of astrological star charts endures. These maps are more than just historical artifacts. They are a testament to humanity's enduring fascination with the stars and their perceived power to shape our lives. They remind us that the heavens have always been more than a scientific puzzle. They are a mirror of our hopes, fears, and dreams. And as we'll see next, this blend of science and symbolism continues to influence the way we map and interpret the cosmos, even in the modern era. The invention of the telescope in the early 17th century marked a seismic shift in humanity's relationship with the stars. For millennia, astronomers had relied on the naked eye to chart the heavens, but the telescope offered a radical new perspective, one that revealed the cosmos in breathtaking detail. Suddenly, the night sky wasn't just a scattering of distant lights. It was a dynamic, ever-changing landscape filled with wonders waiting to be discovered. This revolutionary tool didn't just enhance celestial cartography. It transformed it, opening a window into the universe that forever changed how we see ourselves within it. Galileo Galilei was among the first to harness the power of the telescope for astronomical observation, and his discoveries were nothing short of groundbreaking. Pointing his instrument toward the heavens in 1609, Galileo observed the moon's cratered surface, shattering the ancient belief that celestial bodies were perfect and unchanging. He also discovered the 4 largest moons of Jupiter, now known as the Galilean moons, which provided compelling evidence against the geocentric model of the universe. These observations, meticulously recorded in his work Sidereus Nuncius, or the Starry Messenger, challenged centuries of established thought and laid the foundation for modern astronomy. Galileo's telescope didn't just reveal new celestial objects, it revealed a universe far more complex and dynamic than anyone had imagined. But Galileo wasn't alone in his quest to explore the heavens through this new lens. Across Europe, astronomers like Johannes Kepler and Christian Huygens used telescopes to make their own groundbreaking discoveries. Kepler refined the design of the refracting telescope, improving its clarity and precision, while Huygens used his observations to study Saturn's rings and discover its moon, Titan. These early pioneers demonstrated the telescope's potential not just as a tool for observation, but as a catalyst for scientific discovery. Each new observation brought with it a deeper understanding of the cosmos, from the phases of Venus to the intricate structure of the Milky Way. The impact of the telescope on celestial mapping was profound. Before its invention, star charts were limited to what could be seen with the naked eye, about 6,000 stars. But with the telescope, astronomers began to catalogue tens of thousands of stars, revealing a universe far more vast and intricate than previously thought. Nebulae, once thought to be faint clouds, were revealed as distant galaxies, each containing billions of stars. The Andromeda Galaxy, for instance, was first observed through a telescope, challenging the notion that the Milky Way was the entirety of the universe. These discoveries not only expanded the boundaries of celestial cartography, but also reshaped humanity's understanding of its place in the cosmos. The telescope also brought a new level of precision to star mapping. By magnifying the night sky, astronomers could measure the positions of stars and planets with unprecedented accuracy, leading to more detailed and reliable star charts. This precision was crucial for navigation, as sailors now had access to more accurate celestial maps to guide their voyages. But the telescope's impact went beyond practicality. It sparked a sense of wonder and curiosity that continues to drive astronomical exploration today. The universe, once seen as static and unchanging, was revealed to be a dynamic, ever-evolving tapestry of stars, planets, and galaxies. What's remarkable is how quickly the telescope transformed our understanding of the cosmos. In just a few decades, it went from a novel invention to an indispensable tool for astronomers, opening up new frontiers of discovery. The stars, once distant and mysterious, became objects of scientific inquiry, their movements and properties laid bare by the power of magnification. This new chapter in celestial cartography wasn't just about mapping the stars, it was about exploring the very fabric of the universe, a journey that continues to inspire us to this day. And as we'll see next, the telescope was just the beginning of a technological revolution that would take us even further into the mysteries of the cosmos. The stars that guided ancient mariners and inspired myth makers are the same stars we study today, bridging the gap between past and present in the field of astronomy. While modern technology has transformed how we observe the cosmos, the legacy of ancient star maps remains deeply embedded in the way we understand the universe. From the constellations we name to the celestial events we track, the work of early astronomers continues to shape our exploration of the heavens in ways that are both profound and practical. Take, for example, the constellations themselves. Many of the star patterns we recognize today, Orion, Ursa Major, Scorpius, were first mapped by ancient civilizations. These groupings aren't just arbitrary, they're cultural artifacts reflecting the stories and beliefs of the people who named them. While modern astronomers have added new constellations to reflect more contemporary themes, the core framework established by the Greeks, Babylonians, and others remains intact. This continuity reminds us that the stars are more than just scientific objects. They're a shared heritage, connecting us to the countless generations who looked up at the same night sky and wondered what lay beyond. But the influence of ancient star maps goes beyond names and stories. Modern astronomers often turn to these early records to study historical celestial events such as supernovae and comets. For instance, the Crab Nebula, one of the most studied objects in the sky, was first observed by Chinese astronomers in 1054. Their detailed records of this guest star provide invaluable data for understanding the life cycles of stars and the nature of supernovae. Similarly, ancient observations of Halley's Comet, dating back to 240 BCE, helped scientists track its orbit and predict its future appearances. These historical records are like time capsules, offering a glimpse into the cosmos as it was seen through the eyes of our ancestors. The precision of ancient star maps also continues to astound researchers. The meticulous observations of Hipparchus and Ptolemy, for example, laid the groundwork for modern celestial coordinate systems. Today, astronomers still rely on these principles to map the positions of stars, planets, and galaxies. The tools may have evolved from astrolabes to space telescopes, but the fundamental concepts remain the same. This enduring relevance is a testament to the ingenuity of early astronomers whose work has stood the test of time. Perhaps most importantly, ancient star maps remind us of the universality of human curiosity. Whether it's a Babylonian priest tracking planetary movements or a modern astrophysicist studying black holes, the desire to understand the cosmos transcends time and culture. These early maps are more than just historical artifacts. They're a reminder of our shared journey to explore the mysteries of the universe. And as we continue to push the boundaries of what we know, we're building on the foundation laid by those who came before us. The past and present are intricately intertwined in the study of the stars, each shedding light on the other. Ancient star maps aren't just relics of a bygone era. They're living documents still guiding us as we navigate the vast expanse of the cosmos. And as we look to the future, we're reminded that the stars are not just points of light in the sky. They're a bridge between generations, a testament to humanity's enduring quest to understand the universe and our place within it. Preserving ancient star maps is no simple task. These delicate artifacts, crafted from materials as varied as parchment, papyrus, and stone, have endured centuries of wear and tear, yet they remain vulnerable to the passage of time. Parchment manuscripts, for instance, are highly susceptible to moisture, light, and even the oils from human hands. stone carvings, while more durable, face their own challenges from weathering and erosion to human interference. Each map tells a story, not just of the stars but of the people who created it, and losing even one would mean losing a piece of our shared history. Modern technology has become a vital ally in the effort to protect these priceless artifacts. Digital scanning, for example, allows researchers to create high-resolution copies of fragile manuscripts without risking damage to the originals. These digital replicas can be studied, shared, and even displayed in ways that the originals cannot. In some cases, 3D modeling is used to capture the intricate details of stone carvings or other three-dimensional artifacts. These models not only preserve the physical appearance of the object, but also allow researchers to explore it in ways that would be impossible with the original. Imagine being able to zoom in on every scratch, engraving, and faded symbol, uncovering details that might otherwise go unnoticed. Museums and archives play a crucial role in this preservation effort. Institutions like the British Library, the Vatican Archives, and the Metropolitan Museum of Art house some of the world's most important celestial maps, carefully controlling temperature, humidity, and light to slow the process of decay. But preservation isn't just about protecting the physical object, it's also about making these treasures accessible to the public. Exhibitions, both physical and virtual, allow people to experience the beauty and significance of these maps, sparking curiosity and a deeper appreciation for the history of astronomy. Yet, even with these advancements, challenges remain. Some maps are so fragile that they cannot be handled or displayed at all, while others are scattered across the globe, making it difficult to study them as a cohesive collection. The process of digitization itself can be time-consuming and expensive, requiring specialized equipment and expertise. And while technology can help preserve the physical form of these artifacts, it cannot fully capture the cultural and historical context that gives them meaning. Despite these challenges, the effort to preserve ancient star maps is more than worth it. These artifacts are not just relics of the past, they are bridges to our ancestors, offering insights into how they understood the cosmos and their place within it. By safeguarding these maps, we ensure that future generations can learn from the past, drawing inspiration from the same stars that guided humanity for millennia. And as we continue to explore the heavens with ever more advanced tools, these ancient maps remind us that our journey to understand the universe is a story that began long before us, and one that will continue long after. The preservation of these celestial treasures is a testament to our commitment to honoring the past while reaching for the stars. And as we'll see next, this connection between the ancient and the modern continues to shape the way we explore the cosmos, blending the wisdom of the past with the innovations of the present. The stars have always held a sacred place in human culture, serving not just as navigational aids or scientific curiosities, but as profound symbols of the divine. Across civilizations, celestial cartography became a way to bridge the earthly and the spiritual, aligning human lives with the rhythms of the cosmos. From the towering pyramids of Egypt to the intricate star temples of India, the heavens were woven into the very fabric of religious practice, creating a tapestry where science and spirituality intertwined. In ancient Egypt, the alignment of the pyramids with celestial bodies wasn't just an architectural marvel, it was a spiritual statement. The Great Pyramid of Giza, for instance, is famously aligned with Orion's belt, a constellation associated with Osiris, the god of the afterlife. This alignment wasn't accidental. It reflected the Egyptians' belief that the pharaohs, like Osiris, would ascend to the stars after death. The pyramids themselves were more than tombs. They were cosmic gateways designed to guide the souls of the deceased to their eternal home among the stars. Every stone, every angle was a deliberate act of celestial worship, a testament to the belief that the heavens were a mirror of the divine order on earth. Far to the east, in the Indian subcontinent, star maps took on a different but equally profound role. Hindu and Buddhist cosmologies saw the universe as a vast, interconnected web, with the stars serving as both physical and spiritual markers. Temples were often designed to align with specific celestial events, such as the solstices or equinoxes, creating a sacred architecture that mirrored the heavens. The Brihadiswara temple in Tamil Nadu, for example, is aligned so that the sun's rays illuminate the inner sanctum on specific days of the year, symbolizing the union of the divine and the earthly. In Buddhist tradition, mandalas' intricate geometric designs were used as celestial maps, guiding practitioners through meditative journeys that mirrored the structure of the universe. These sacred star maps weren't just symbolic, they were tools for spiritual transformation, helping individuals align their inner lives with the cosmic order. The Maya of Central America also saw the stars as deeply spiritual, integrating celestial events into their religious calendars. The movements of Venus, for instance, were meticulously tracked and used to time important rituals and ceremonies. The Maya believed that the gods communicated through celestial phenomena, and their star maps were a way to decode these divine messages. The Caracol Observatory at Chichen Itza, with its carefully aligned windows and corridors, was both a scientific instrument and a sacred space where the heavens were studied not just for their physical properties but for their spiritual significance. What unites these diverse traditions is the idea that the stars are more than just distant lights. They are a reflection of the sacred, a way to connect the human and the divine. Celestial cartography in this context wasn't just about mapping the sky, it was about mapping the soul, creating a guide for both physical and spiritual journeys. The stars served as a reminder that the cosmos is not just something to be observed but something to be revered, a vast and mysterious expanse that holds the key to understanding both the universe and ourselves. This intersection of religion and science in celestial cartography reveals a deeper truth about humanity's relationship with the stars. For millennia, the heavens have been a source of both wonder and wisdom, inspiring us to look beyond the visible and seek meaning in the infinite. Whether through the alignment of a temple, the creation of a sacred calendar, or the meditative journey of a mandala, the stars have always been more than just points of light. They are a bridge between the material and the spiritual, a testament to our enduring quest to understand the mysteries of existence. And as we'll see next, this quest continues to shape the way we explore the cosmos, blending the insights of the past with the discoveries of the present. The stars have long been more than just celestial bodies. They have been a wellspring of inspiration for poets, writers, and artists, shaping the way we tell stories and express our deepest emotions. From the intricate star maps embedded in epic poems to the luminous night skies depicted in Renaissance masterpieces, the heavens have served as a canvas for human creativity, blending science and art in ways that continue to captivate us today. One of the most striking examples of this fusion is Dante Alighieri's Divine Comedy, a literary masterpiece that weaves a celestial map into its very structure. In the final cantos of Paradiso, Dante describes ascending through the celestial spheres, each one representing a different level of divine order and perfection. The stars in his vision are not just points of light, they are symbols of hope, redemption, and the eternal quest for understanding. Dante's celestial imagery reflects the medieval worldview, where the heavens were seen as a reflection of God's plan, but it also speaks to a universal truth, that the stars have always been a source of wonder and meaning. This fascination with the heavens extended far beyond literature. In the Renaissance, artists turned to the stars as a way to explore themes of beauty, mystery, and the divine. Paintings like Albrecht Dürer's Melancholia I and Johannes Vermeer's The Astronomer are filled with celestial imagery, from globes depicting the constellations to rays of light streaming through windows like beams from distant stars. These works capture the spirit of an era when science and art were deeply intertwined, each feeding the other's curiosity and ambition. The night sky became a recurring motif, a way for artists to evoke the infinite and the sublime, reminding viewers of the vastness of the universe and the smallness of humanity within it. Even in more secular works like Vincent van Gogh's The Starry Night, the stars take on a life of their own, swirling and pulsating with an almost otherworldly energy. Van Gogh's vision of the night sky is not just a depiction of what he saw, it's an expression of how he felt, a testament to the emotional power of celestial imagery. But the influence of celestial cartography on art and literature isn't confined to the past. Even today, the stars continue to inspire creators across the globe. Modern poets like Tracy K. Smith and Mary Oliver have written movingly about the night sky, using its vastness as a metaphor for the human condition. In science fiction, authors like Isaac Asimov and Ursula K. Le Guin have imagined entire galaxies filled with worlds and civilizations, drawing on the same sense of wonder that ancient astronomers felt when they first mapped the stars. Visual artists, too, have embraced the heavens as a source of inspiration, from the abstract star fields of Agnes Pelton to the cosmic installations of Olafur Eliasson. These works remind us that the stars are not just objects of scientific study, they are a wellspring of creativity, a way to explore the mysteries of existence and our place within it. What makes this connection between celestial cartography and the arts so enduring is its universality. The stars are a shared language, one that transcends time, culture, and discipline. Whether it's a medieval poet envisioning the celestial spheres or a modern painter capturing the shimmering beauty of the Milky Way, the heavens have always been a source of inspiration and awe. They remind us that the universe is not just something to be understood, it's something to be felt, to be imagined, and to be celebrated. And as we'll see next, this creative dialogue between humanity and the stars continues to evolve, shaping the way we see the cosmos and ourselves within it. The future of celestial cartography is being shaped by technologies that would have seemed like science fiction just a few decades ago. Satellites orbiting Earth, like the Hubble Space Telescope and its successor, the James Webb Space Telescope, are capturing images of the cosmos with unprecedented clarity. These instruments allow us to see galaxies billions of light years away, revealing details about their formation and evolution. Computer modeling, too, is revolutionizing the way we map the stars. Advanced algorithms can simulate the positions and movements of celestial bodies, creating dynamic, three-dimensional maps that bring the universe to life in ways ancient astronomers could only dream of. These tools aren't just expanding our knowledge, they're transforming how we visualize and interact with the cosmos. One of the most exciting frontiers in modern celestial cartography is the mapping of exoplanets' worlds beyond our solar system. Using data from telescopes like NASA, Kepler, and TESS missions, astronomers have identified thousands of these distant planets, each with its own unique characteristics. Some are rocky, like Earth, while others are gas giants or even super-Earths with conditions unlike anything we've seen before. Mapping these exoplanets involves more than just pinpointing their locations. It's about understanding their atmospheres, climates, and potential for life. This work builds on the same principles that guided ancient stargazers' observation, measurement, and a relentless curiosity about what lies beyond the horizon. The difference is that today, we're mapping not just the stars but entire worlds, pushing the boundaries of what we thought was possible. Distant galaxies are another focus of modern celestial cartography. Telescopes like the James Webb Space Telescope are peering deep into the universe's past, capturing light from galaxies that formed just a few 100 million years after the Big Bang. These observations are helping astronomers create detailed maps of the early universe, revealing how galaxies cluster and evolve over time. These maps aren't just scientific tools, they're windows into the history of the cosmos, showing us how the universe has changed over billions of years. It's a humbling reminder that the stars we see today are part of a much larger, ever-changing story. What's truly remarkable about this new era of celestial cartography is how it involves people from all walks of life. Citizen science projects like those hosted by platforms such as Zooniverse invite amateur astronomers and enthusiasts to contribute to real scientific research. Whether it's classifying galaxies, identifying exoplanets, or tracking asteroids, these projects allow anyone with an internet connection to become part of the mapping process. This democratization of science echoes the collaborative spirit of ancient astronomers who worked together across cultures and generations to map the heavens. Today, thanks to technology, that spirit is stronger than ever. As we look to the future, it's clear that the art of mapping the stars is far from finished. From ancient clay tablets to cutting-edge satellite imagery, celestial cartography has always been a reflection of humanity's curiosity and ingenuity. The tools may have changed, but the goal remains the same: to understand the cosmos and our place within it. And as new technologies continue to push the boundaries of what we can see and discover, one thing is certain: the stars will always guide us, just as they have for thousands of years. As we chart the stars and planets with ever greater precision, we're also navigating a new frontier of ethical questions. The advancements in celestial cartography, while awe-inspiring, come with complexities that demand careful consideration. Who owns the data we gather from the cosmos? Should the stars, or even the planets we map, be subject to commercial interests? These questions aren't just philosophical. They're becoming increasingly urgent as private companies and nations race to explore and exploit space. The commercialization of space, for instance, raises concerns about equity and access. If celestial mapping becomes a tool for profit, will the benefits of this knowledge be shared, or will they be monopolized by a select few? The idea of corporations staking claims on asteroids or celestial bodies for mining ventures challenges our understanding of space as a shared, universal resource. Cultural concerns also play a significant role in this ethical landscape. For many indigenous communities, the night sky holds profound spiritual and cultural significance. Constellations aren't just patterns of stars, they're part of living traditions, carrying stories and wisdom passed down through generations. When modern celestial mapping projects overlook or disregard these cultural perspectives, they risk erasing centuries of knowledge and connection to the cosmos. This raises an important question: how can we ensure that scientific progress respects and includes the voices of those who have long seen the stars as more than just objects to be studied? Environmental considerations add another layer to this ethical puzzle. While space may seem infinite, our ability to explore and map it is not without consequences. The growing number of satellites orbiting Earth, for example, poses risks to both astronomy and the environment. Light pollution from these satellites can interfere with ground-based observations, while space debris threatens the sustainability of future missions. As we push further into the cosmos, we must ask ourselves, how do we balance the pursuit of knowledge with the responsibility to protect both Earth and space from harm? Perhaps the most pressing challenge is fostering international cooperation in celestial mapping. The stars belong to no single nation or corporation, yet the tools and resources needed to explore them are often controlled by a handful of powerful entities. Without collaboration, there's a risk that the benefits of celestial cartography, whether scientific, economic, or cultural, will be unevenly distributed. Initiatives like the International Space Station and global astronomical partnerships offer hope, showing that shared goals can transcend borders. But as the stakes grow higher, so too must our commitment to working together. These ethical dilemmas aren't just hurdles to overcome, they're opportunities to redefine how we approach the cosmos. By addressing questions of ownership, cultural respect, and environmental stewardship, we can ensure that celestial cartography remains a force for good, a tool not just for discovery but for unity and progress. The choices we make today will shape the future of this ancient art, guiding how we explore the heavens and what we leave behind for the generations to come. And as we continue to map the stars, we're not just charting the universe, we're charting a path toward a more thoughtful and inclusive vision of our place within it. Celestial cartography isn't just a relic of the past or a tool for scientists, it's a vibrant part of education, sparking curiosity and wonder in students of all ages. From classrooms to planetariums, star maps serve as gateways to the cosmos, helping young minds grasp the vastness of the universe while connecting them to the rich history of human exploration. By blending ancient traditions with modern technology, educators are using celestial cartography to inspire the next generation of astronomers, explorers, and dreamers. One of the most powerful ways star maps are used in education is through hands-on activities. Imagine a group of students gathered under a clear night sky, telescopes pointed upward as they trace the outlines of Orion or locate the North Star. These moments of discovery aren't just about learning constellations, they're about fostering a sense of connection to the cosmos. Creating star charts can be equally transformative. By plotting the positions of stars and planets, students not only learn the basics of celestial coordinates, but also gain a deeper appreciation for the precision and artistry behind ancient star maps. These activities make astronomy tangible, turning abstract concepts into something students can see, touch, and experience. Planetariums play a crucial role in bringing the night sky to life, especially in urban areas where light pollution obscures the stars. Inside these domed theaters, students can journey through the solar system, witness the birth of stars, or explore distant galaxies, all from the comfort of their seats. Planetarium shows often incorporate stunning visuals and interactive elements, making complex astronomical ideas accessible and engaging. For many students, a visit to a planetarium is their first encounter with the wonders of the universe, an experience that can ignite a lifelong passion for science and exploration. Educational programs and initiatives are also expanding access to celestial literacy. Organizations like NASA and local astronomy clubs offer resources for teachers, from lesson plans to stargazing guides, making it easier to incorporate astronomy into the classroom. Events like International Observe the Moon Night and Astronomy Week bring communities together, encouraging people of all ages to look up and wonder. These programs don't just teach facts about the stars, they cultivate a sense of curiosity and adventure, reminding us that the universe is full of mysteries waiting to be solved. What makes celestial cartography such a powerful educational tool is its ability to bridge the past and the future. When students learn about the star maps of ancient civilizations, they're not just studying history, they're seeing how humanity's understanding of the cosmos has evolved over time. This connection to the past inspires a sense of continuity, showing that the stars have always been a source of knowledge, inspiration, and wonder. At the same time, modern star maps and digital tools offer a glimpse into the future, where new discoveries are constantly reshaping our understanding of the universe. Education is more than just a way to pass on knowledge, it's a way to preserve and build upon the legacy of celestial cartography. By teaching students to map the stars, we're not just equipping them with skills, we're nurturing a sense of curiosity and exploration that will carry them, and all of us, forward into the unknown. And as we continue to explore the cosmos, it's this spirit of learning and discovery that will ensure the stars remain a source of inspiration for generations to come. The stars have always been a universal language transcending borders and cultures, and today they continue to bring humanity together in an extraordinary way. Modern celestial cartography is no longer the work of lone stargazers or isolated civilizations. It's a global effort, uniting astronomers, engineers, and scientists from every corner of the planet. One of the most ambitious examples of this collaboration is the Gaia mission, a European space agency project that has revolutionized our understanding of the Milky Way. Launched in 2013, Gaia has meticulously mapped the positions, distances, and motions of over 1 billion stars, creating the most detailed three-dimensional map of our galaxy ever produced. This monumental achievement wouldn't have been possible without the contributions of researchers and institutions from dozens of countries, each bringing their expertise to the table. International partnerships are the backbone of projects like Gaia, enabling the pooling of resources, knowledge, and technology. From the United States to Japan, from South Africa to Australia, astronomers work together to analyze the vast amounts of data collected by space telescopes and ground-based observatories. These collaborations aren't just about sharing data, they're about building a shared understanding of the cosmos. By combining their strengths, scientists can tackle questions that no single nation or team could answer alone. Questions about the origins of galaxies, the nature of dark matter, and the ultimate fate of the universe. This spirit of cooperation reflects a profound truth. The stars belong to everyone, and their mysteries are best unlocked together. What's particularly inspiring about these global efforts is how they echo the work of ancient astronomers. Just as the Babylonians, Greeks, and Chinese once shared their celestial knowledge along trade routes, modern astronomers exchange insights across digital networks, creating a living tapestry of discovery. The tools have changed, but the goal remains the same: to map the heavens and understand our place within them. Missions like Gaia don't just build on the legacy of ancient star maps, they honor it, showing that the quest to explore the cosmos is a timeless human endeavor. But these collaborations do more than advance science. They remind us of our shared humanity. In a world often divided by differences, the stars serve as a unifying force, drawing us together in a common pursuit of knowledge. Whether it's a researcher in Brazil analyzing data or an engineer in Germany fine-tuning a telescope, each contribution is a thread in a larger story, one that spans continents, cultures, and centuries. This collective effort underscores a powerful idea: that the universe is not just something to be studied, but a mirror reflecting our capacity for curiosity, cooperation, and wonder. As we look to the future, the importance of global collaboration in celestial mapping will only grow, with new missions on the horizon like the James Webb Space Telescope and the Vera-C. Rubin Observatory, the possibilities for discovery are limitless. Each project is a testament to what we can achieve when we work together, guided by the light of the stars and the shared belief that the cosmos is a frontier worth exploring. And as we continue this journey, we're not just mapping the universe, we're mapping the best of what humanity can be. There's something timeless about the stars, something that stirs a deep, almost primal sense of wonder in all of us. Whether it's the shimmering beauty of a clear night sky or the profound mystery of what lies beyond, the stars have a way of drawing us in, inviting us to dream, to question, and to explore. They've been a source of inspiration for poets, a guide for explorers, and a canvas for scientists, yet their allure remains as powerful today as it was thousands of years ago. What is it about these distant lights that continues to captivate us generation after generation? The answer lies not just in what the stars are, but in what they represent: a connection to our past, a window into the universe, and a mirror of our own humanity. Celestial cartography, the art of mapping the stars, is more than just a scientific endeavor. It's a bridge between eras. When we look at an ancient star chart, we're not just seeing a record of astronomical observations, we're glimpsing the thoughts, beliefs, and dreams of the people who created it. The same constellations that guided Babylonian priests or Polynesian navigators still shine above us today, linking us to those who came before. This continuity is profoundly moving. It reminds us that no matter how much the world changes, the stars remain a constant, a shared heritage that transcends time and culture. In mapping the heavens, we're not just charting the cosmos, we're tracing the footsteps of our ancestors, honoring their curiosity and ingenuity. But the stars do more than connect us to the past. They also open our eyes to the vastness of the universe. Gazing at the night sky, we're confronted with a humbling truth. We are but a small part of something infinitely larger. This realization can be both awe-inspiring and sobering. It challenges us to think beyond our immediate concerns, to consider our place in the grand tapestry of existence. The stars remind us that the universe is full of mysteries waiting to be uncovered, and that there's always more to learn, more to discover. In a world that often feels fragmented and chaotic, the night sky offers a sense of perspective, a reminder that we're all part of the same cosmic story. Emotionally, the stars have a unique power to evoke a sense of wonder and introspection. For many, stargazing is a deeply personal experience, a moment to reflect on life's big questions. What is our purpose? Are we alone in the universe? These questions may not have easy answers, but the act of asking them, of looking up and wondering, is itself a profound act of connection. The stars invite us to dream, to imagine, and to feel a sense of kinship with the countless others who have gazed at the same sky and asked the same questions. They remind us that, despite our differences, we're all united by our shared curiosity about the cosmos. Philosophically, the stars challenge us to think about what it means to be human. They remind us that we are both insignificant and extraordinary, insignificant in the face of the universe's vastness, yet extraordinary in our ability to understand and explore it. This duality is at the heart of our relationship with the stars. They humble us, but they also inspire us. They remind us that the universe is not just something to be studied, but something to be experienced, to be felt. In mapping the stars, we're not just seeking answers, we're seeking meaning, a way to make sense of our place in the cosmos. As we reflect on the enduring allure of the stars, it's clear that they are more than just points of light in the sky. They are a source of beauty, a symbol of mystery, and a reminder of our shared humanity. They connect us to our ancestors, to each other, and to the infinite possibilities of the universe. And as we continue to explore the heavens, we're reminded that the stars are not just a destination. They are a journey, one that invites us to look up, to dream, and to discover the boundless wonder of the cosmos. From the earliest star charts etched into clay tablets by Babylonian priests to the cutting-edge digital maps created by modern astronomers, the story of celestial cartography is a testament to humanity's unyielding curiosity and ingenuity. Over thousands of years, this ancient art has evolved from a way to predict the seasons and navigate the seas to a tool for exploring distant galaxies and unlocking the secrets of the cosmos. Along the way, it has shaped cultures, inspired myths, and driven scientific breakthroughs, leaving an indelible mark on human history. Whether it's the intricate star maps of the Maya, the precise calculations of Ptolemy, or the breathtaking images captured by the James Webb Space Telescope, each chapter in this story reflects our enduring desire to understand the universe and our place within it. What makes celestial cartography so remarkable is how it bridges the past and the present. The same stars that guided ancient sailors across uncharted waters now guide us as we explore the farthest reaches of space. The constellations that once told stories of gods and heroes now help us study the life cycles of stars and the formation of galaxies. In a sense, every star map is a time capsule, connecting us to the countless generations who looked up at the same night sky and wondered what lay beyond. This continuity reminds us that the stars are more than just objects of scientific study. They are a shared heritage, a source of inspiration, and a testament to our collective journey of discovery. As we reflect on the legacy of celestial cartography, it's impossible not to feel a sense of awe. The stars have always been a mirror reflecting our hopes, dreams, and aspirations. They've guided explorers, inspired artists, and challenged scientists to push the boundaries of what we know. And they continue to do so today, reminding us that the universe is full of mysteries waiting to be uncovered. As Carl Sagan once beautifully observed, we are made of star stuff. The atoms that form our bodies, the air we breathe, and the world we inhabit were forged in the hearts of stars billions of years ago. In a very real sense, we are connected to the cosmos, not just as observers but as part of its story. So, the next time you find yourself under a clear night sky, take a moment to look up. Let the stars remind you of the incredible journey we've taken, from ancient stargazers mapping the heavens with nothing but their eyes to modern scientists unraveling the mysteries of black holes and dark matter. Let them inspire you to dream, to question, and to explore. And as you gaze at those shimmering points of light, remember that you're part of a legacy that stretches back thousands of years, a legacy of wonder, discovery, and connection. We'd love to hear your thoughts on this journey through the stars. What fascinates you most about celestial cartography? Have you ever tried stargazing or mapping the night sky? Share your experiences in the comments below, and don't forget to subscribe for more explorations of historical mysteries. Until next time, keep looking up because the stars have so much more to